Welcome, everyone, to Mark Voids a Warranty. I'm Mark. This is my hammer. This is the warranty we're voiding today, the iSteady Pro. It's a little gimbal cam by Hohum? Hohum? I don't know. Hohum, maybe. Probably it. Anyways, it's called the iSteady Pro. It's something I picked up off of a discount site, so it should be fun. But I've got a special treat for us today. And hello, Andrew. We've got a fancy PCR COVID test. My wife had to take this at work. And I asked her, if there was anything interesting about it. And she sent me that it had batteries. So I said, hey, we need to see that. So I don't know exactly what I'm getting into. There's a vial of what I'm certain is biohazardous liquid. Yay? I don't know. So, anyhow, do you guys want to do this one first, or do you want to do it after the gimbal? You got to let me know. In the meantime, I'm going to see what I can do to get rid of that vial over here in the trash can. And the answer is nothing. It is built right in. Great. Well, you know what I could do is open the vial, maybe. And we could let that clean out and dry out. Maybe. Okay. Hey, Brian. All right, we're doing the gimbal first. That'll give this a chance to dry. But we do have it. So, interesting. All right. Ready for the iSteady Pro 2. Brand new. I don't know what to tell you. I've got nicer gimbals, bigger gimbals. I don't need a tiny gimbal. As I said in the announcement, maybe if I'd met 5 months ago, or 5 years ago, I'd be impressed. Did you hear about the digital pregnancy tests that literally were just regular paper tests with an optical sensor to detect if there was a line or not? Nice. I did not hear about that, but there's plenty of tests that are nothing more than looking for color changes. Pregnancy, what do they do for that? Is it alpha-fetoprotein or beta-human chorionic gonadotropin? I don't know. Who knows that stuff? But yeah, they're just detecting changes. We've got a manual. We don't need to get into that. A desiccant. We've got a couple USB cables. I guess I can give you the top-down view. And then we've got the iSteady Pro. So, nice little case. Pity. All right, so our gimbal looks like it has restricted motion. So I'm just twisting it around. So here we start 360. So it looks like we get, what was that? 180, 360, plus another 180, and then we click on that axis. Here we've just got 360. These roll yaw, I always forget how these work because they go at an angle. And then we've got about 360 on that axis. Some screw holes that we should be able to get into relatively easily. A little joystick to connect stuff. Andrew, that's a great suggestion. To move the picture-in-picture to the upper right, that would require me to figure out how to move it to the upper right. So I will have to prepare that for next time because I don't know right off. If I had somebody running a control room for me, I'm sure they could do that, but I don't want to pause everything while I poke around and look foolish. But I will look into that for you. All right, so I'm just going to start. That does not feel like it's engaging. I guess the first thing I have to do is find the right too small. We've definitely got some Goldilocks syndrome going on. this doesn't work, I've got some screwdrivers on the other side of the room I can grab. If I can't find them right. Nope, that one's too small. Definitely some Goldilocks syndrome going on. What else do we have here? Too small? Boy, I tell you. This does not want to go the easy way, does it? Also too small. Maybe I'm just missing the size on this thing altogether. I might have to go to the other side of the room. Nope, we got it. Just because I'm curious, is there a reason you want it in the upper right corner? Is it because I was working off to the side there? Or would that make life better for a different reason? And Brian, what are you up to today? I see bottom of the morning. All right. We got some troublemakers from the Pacific Northwest. Thanks for coming out, guys. I don't know if you noticed, but we had Paul Daly on the Adafruit Show and Tell. That was nice. Okay, so we are now separate. We've got two wire harnesses that I'm just going to remove. So now we've got a top section with some IMUs and whatnot. We'll get into that. And we've got a bottom section with a controller. Got a charge port over here. That's a weird USB to be there. Huh. Trigger. Some LEDs. So now we've got to get into this. There's a piece of rubber here that's different than the other plastic. We could have something hiding under there. Or, and I don't know, but sometimes you find things hiding under stickers. Made in China. Oh, look what we found. Secrets. They hide the sticker, the switches under there. Okay, we've got some comments. Original Circuit is curious to see if this has a single IC driver per motor or separate FETs, and any idea when this, what this retailed for when released. Yeah, so it allegedly, according to the website I got this from, Woot, it was originally $80. I got it for a little less than half that. I have a budget of about $40 per episode. And Brian says maybe that's camera out and not to charge. I don't know what that is. It could also be it's a firmware upgrade option. Okay, so those screws are loose. Those are gone, but it doesn't feel like it's ready to come apart yet. Well, you know what that means, folks. Time for me to get a little crazy. Watch your ears. That might have done it, actually. It did. There's still something holding it on up here. And there... I don't know if that's a... That doesn't feel like a sticker. But it is stuck. Just a thick piece of plastic. Whoops. Let's see here. Kind of odd that they would hide screws over here when they had them visible just centimeters away, but they did. Those tricky boogers. So we've got a couple more coming out here too. Andrew says he would like to know how this compares to another one, the DJI. And Andrew, I don't know. I've never played with the DJI one. I do have a Z1, I don't know how you pronounce it. That's really good, but don't know about this one. Okay, another connection here. and here. So lots of wire IDC connectors and a pretty respectable, hefty battery in there that we're going to, fortunately, I think, be able to get out safely. The other nice thing so far is all of these screws have the same head. So taking it apart, putting it back together, not so bad. The joystick popped right off. That was connected to this board that I'll take out in just a second and we'll take a look at. So it was those two screws that were hiding underneath the sticker that I broke when I smashed it. Yeah, this is probably a clone. You know, if you go over to some of the offshore places, they don't have the same ideas of intellectual property that the rest of us do. And that's good and bad. As far as innovation goes, it's wonderful, right? You get a bunch of guys together in a bar, you know, they all have their own manufacturing factories, and after work they get together, have a beer or two, and then they talk about stuff, and they come up with ideas, like the hoverboard. But at the same time, if you have an idea, they've got absolutely no compunction about stealing it. You know, so that's unfortunate. So, we are at a very respectable 49 viewers right now. So welcome everyone. Feel free to join in. Let us know how you got here. Okay, first board coming out. So this is the switch. So there's a trigger on the front. And all this board does is, apparently, it's a two-sided copper switch. So we can talk about that and how they might have saved a little bit of money here. Anyhow, that's the back side. Here's the front side. That's where that switch was connected. We're going to pull that out, and then we're going to take a look at it. We are now up to 67 viewers. Let me tell you this. We are only 4 viewers away from 500. When we get to 500, I am taking apart a mini tens of $1,000 broadcast video camera lens. I'm only 4 away. Do you want to be one of those 4? I think you do. So join me. Sign up, like, subscribe, hit the bell. Unless you're already subscribed, in which case I don't want you to subscribe. Okay, next board out. Once we get all the boards out, we're going to take a look and investigate them. Actually, I think we've got all of the boards out of the controller. So let's move to a higher magnification and take a look. Right now, all I'm doing is removing all of these IDC connectors. They're not IDC, they're individual wire. Okay, let's move to this. Here is the first board, at least at this magnification level. We've got the joystick here that we get the movement from. We've got a it's a selector switch, but so it's a momentary selector switch, and it's a return to center, but I don't know that I've ever seen one internally mounted before. That's interesting. I don't think I would have thought of that. I probably would have put it on the outside. Why? I have no idea. It's fine right there. That is really interesting. A couple momentary tactiles. This appears to be an inductor. We've got a bunch of caps, and this must be a power management IC, or one of these is. We'll look at it under the microscope in just a second. Vias, so these just look like plated through hole vias, so we're not looking at any micro technology. I might change my opinion on that when we get it flipped over. And then on the back side, we've got our test points all on one side. So that's one board. We'll look at that under the microscope in not too long. We've got another board. This is the one that had our USB connectors on it. Typically you see the, like a USB, micro USB B. That's pretty common, but you don't often see the USB-As. So my only assumption there is that this is for some sort of a firmware upgrade. I'm not entirely sure. Jason says, hey, Mark. Hey, Jason Weber. How the heck are you? If I get to 500 now, will I stop what I'm doing and broadcast something else? No, I won't stop. But what I am willing to do is go into a second hour. Although I have to make sure I can get to the lens. The lens is in the other room, and I think it's been a few months since I've put it there. It might have some things on it, but we could definitely do a special Mark Voids a Warranty for that. Anyways, here we are on our second one. Like I said, I find that kind of odd. Another momentary switch, just a side mount, another inductor, so we've got another switching power supply, and then this IC. So we'll get a better idea once we get these things under the microscope. Again, it looks like just regular plated through holes, so nothing too fantastic here. And then the last board out of the bottom controller is this one, and we are at we're looking at a two-sided board with a ton of vias. I mean, relatively speaking, all to support a single switch. Now, this doesn't make much sense unless these all come as a single panel and these are all two-sided. This is just a waste of copper. But I don't know. Let's see. Let's start with this one. We're going to go to our microscope view. Dun, dun, dun. Where's my microscope button? All right. Microscope view live. This is the big fancy push button, the switch trigger button. It is kind of overbuilt. I mean, it's got a nice feel to it, but it's really kind of overbuilt for a trigger switch. See if we can get underneath it. So we just have a tactile switch. There was a spring that flew out there with, so all we're doing is just connecting two contacts. And here's why I'm saying it's a little ridiculous. From a cost standpoint, you could have done this easily out of a single layer PCB. There's just a ton. Okay, there's the spring mechanism there. It didn't bounce far. Anyways, there's just a ton of copper here for no real reason. There's an assortment of vias. I mean, that's good. It's good practice to tie if you've got copper pores, to tie them to other things. I just can't imagine why you need a copper pore here at all. On the back side, it gives you a nice return path, but man, what a waste of copper. You could have done this with a single-sided PCB easy. And the other thing that I question is, connectors are expensive. Yeah, it's surface mount, but it all adds up after a while. Could they not have just done this, put a couple solder holes in it, and then connected the wire right to the board? I would think so. Are you going to save a lot? For you and me, maybe we make 100 of these things. No, it's not going to matter. But for a company, offshore like China, you're making 1,000, 100,000 of these. Every little bit adds up. So if you can save, 30 cents a board or even 5 cents a board, like I said, it adds up. All right. Next board we've got under the microscope is, this is the one with that big fat USB-A and the micro USB. And we're just going to look around and see what it is that we can see. So we've got some LED indicators, and I can probably zoom in on those a little bit. Is that hot glue on the connector? Yes, Andrew, it was. It's pretty common to pot, as they say. You'll either put silicone or hot glue on something to help it stay in place, especially if you're anticipating a lot of mechanical load. So here we have LEDs, and it looks to be possibly a two-color. No, there's only one connector there, one connector there. Just two bond wires, so it's just a single color LED. Nothing too out of the ordinary there. Sorry for the shakiness. I'll try to hold it still, but that's what an LED looks like inside. And by the size of things, those are 0603s or 0805s. And there's just an assortment of those. Something interesting, you can see the vias. Well, maybe you can't, I can. You can see there's like a via copper connection here, and you can see that they missed the drill by a substantial margin. That's a large via to be that off. So their drills appear to be slightly misregistered in those. Here's why that's a problem. If you look at these vias here, look how close, I mean, they're off. If they'd been off a little bit more, another mil, they could have carved out that trace and then disconnected this via from the trace. That's one of the reasons that I always recommend, if you can, add teardrops. They're free, they don't cost anything. And then if the drill does wander, it has to wander that much further before it breaks out. It's just something, a little thing you can do to increase your yield. The copper edges look like they etched very cleanly. So the manufacturer here had their processes dialed in pretty well. I mean, I've seen better, but I mean, for a high production board like this, I've certainly seen worse. It looks, I mean, I would say it looks great. There is flux left on the board. You never want to see that because that lets you know they didn't clean it. Even if you have no clean flux, manufacturing's a dirty process. So even if you have no clean flux, that doesn't mean you have a no clean board. Let's zoom out here if I can. So anytime that they leave flux on, it can sit there and eat through the metals, and it can cause latent failures over time. And you hate to see that. The LED solder connection looks like crap. Well, yeah. Someone in my community was saying that the assembler soldering directly to the board was about 5 times the cost of the connector. Yes, it can be. If you have somebody sitting there doing it, it absolutely can be. If you can turn it into an automated process, it's not. It just depends on the capabilities of the manufacturing facility. Anytime that you put a human in the equation, the price is going to go through the roof. Absolutely. So, anyhow, they did use multiple vias in their copper pores. They used a lot of copper pores. This would take a long time to, well, not a terrifically long, but it would take longer than normal to route. And you don't always need that. As long as you have on the backside a decent solid copper return for these things, you don't need all of the copper on the top. And in fact, it can be a problem. You know, for example, the traces that we have running this way, you're going to want copper on the other side of those so that when the signals change, or, you know, maybe they're power circuits, whatever they are, there's a return path that can form. And if we go to the other side of this, well, we see that, you know, assuming this is a 2-layer board, and I don't know that it is, we can look and see if we can get some hints in a minute. But these things cross. There's no predictable return path for any of this stuff. Let's see if we can see if we can get any hints of extra copper layers. Here we're edge on, and I'm looking for evidence of a core in here. And I'm going to have to zoom in. This is where I wish I had a little more experience, or my buddy Elijah. If you're watching, you got to let me know. That middle layer looks a little too clean. I wonder if there isn't some copper in here, in which case they're using the 2 internal layers as their return paths. Yeah, there it is. I can see the core here pretty cleanly. So they do have extra copper on the middle there. So this might be an HDI board. So with HDI, you know, you do foil on top. I don't know. Anybody out there knows and wants to call me a liar? Call me a liar. I don't mind. But it does look like there might be 2 more layers inside here. And I wonder if we can... Nope. There's 4. I was looking for patterns to see if the patterns go all the way through. 5, 1, 2, 3, 4, 5. Those do. Those do. I was looking to see if there might be a via that doesn't go all the way through. 1, 2, 3, 4. 1. But I don't see any evidence of this. So, oh gosh, I could very well be wrong. That could just be a core of... that could just be a core of fiberglass. Man, I don't know. I don't know. But anyways, going back to things you like to see, things you don't like to see, right? Anytime that you can do multiple vias, tying one layer of copper to the other, that's great. It'll give you a low impedance path. I don't know that you need that many, but anytime you can do more than one, you should do more than one. One of the things I don't see here that I like to see, if you are routing a return path, you also need a vertical return path, and I don't see that here. All of these vias, they just go straight down. Well, what happens to the signal as it transitions from layer, you know, between, or the energy when it goes from layer 1, 2 to layer 3, 4, assuming, of course, there is a layer 2 and 3 in the middle of this board. It's got nowhere to go. So it's not enough to do, just horizontal return paths. You also need vertical ones. More vias. Again, like to see that. Ground, I assume, and again, multiple vias, always good. We've got what appear to be... Oh no, those are mechanical. Those are for this. Never mind. All right. So anyways, let's keep going. We did those 3 boards. Let's go back to taking things apart and keep the party going. All right, so what we've done so far is myrtleize the handle. It was a lot of fun. Given the drill precision and price point, I'd be shocked if this was anything other than the cheapest board orderable. Amazingly enough, it's not. I could save you money on at least one board so far. But I agree with you. Most things these days, they are going for the cheapo. Okay, we are doing pretty good. So original circuit, where are you from? I haven't seen you on the channel in at least a while, but I don't remember you. And Jason Webb, what are you up to? Or Weber, what are you up to? All right, so board, it had 3 retaining screws. I have removed those. More individual wire connectors. Another thing that you can do too is, instead of having these things pluggable, you can press the wires right into connectors on the board. We're going to have to probably remove that. Let's see what else we have. iSteady. This is hiding behind a sticker here. So I'm going to have some screws, I'm sure. Pro 2. Okay. And then there's a inventory tracking sticker. I don't feel anything behind that. So then our last one will be here, but that's going to be hard to get to. So we'll take these other apart too. Still using the same screwdriver. That's nice. I know who you are. Oh. It does sound familiar. Who is original circuit? You got to be somebody from the class. You're not Paul, because Paul cheats and uses a non-YouTube client. Elliot is Elliot made. Who is original circuit? Is original circuit Mark Harris? You're Mark Harris, you stinker. Man, I tell you. Okay, there's that back off. So we've got another PCB. A lot of test points on these. Okay. So this is one of the controller boards. Looks like these mechanical stops are just, looks like they might just be axial bearings. I don't know if those are tapered or not, but we'll pull out a pair of pliers here in a minute and find out. And let's keep going. Ha ha, yes, original circuit, ha ha. You have so many monikers, buddy. It is hard to keep track of who you are. I'm telling you. Are you also responsible for the 1,000 playbacks that I have so far? Usually it's me and the cats. If so, thank you. All right. Another board. This one looks eerily similar to the first one we evaluated. So, original circuit, let me ask you. There are a lot of connectors on this board. How would you save money on that? That one I took off has 1, 2, 3, 4 alone. Okay. Is that everything? Let's find out. Maybe. Well, thank you for telling your Discord about me. That was very kind of you. For those of you that don't know, Mark Harris runs the largest free open source Altium library. If you go to altiumlibrary.com, he's got, I don't know, something like 150,000 components, and he's in the process of adding 160,000 more. And it's free. If you want to, you can give him money, but I recommend that you stiff him just because it would be funnier. No, I'm kidding. You should donate if you use it. Okay, I think I need pliers. Give me one moment. All right. Again, while I have your attention, if you haven't already, and you do enjoy watching me destroy things, and you like the witty repartee, please like, subscribe, smash that bell. Tell your friends, tell your neighbors, tell your friends' neighbors, tell your neighbors' friends. Tell your neighbors' friends' neighbors. Maybe their parents too. I mean, you can even tell your in-laws. I don't care. Okay, so this is interesting. We've got a tapered retaining nut. So right now I am trying to get into the heart and soul of one of these guys to see what it takes to pull it apart, and we just got into the motor a lot faster than I expected, actually. Is it possible to... It probably is possible to slide those things through, but that takes time. Who has time? So we've got these little low-profile bearings. By the looks of them, that looks like it's about 8mm interior, maybe 12 or 14 exterior. I don't know, 6 to 8mm width. And then we've got all of these Multi-coil stator windings. That's cool. Or maybe they're not stators. No, they're... Actually, I don't know how you would do it in a motor like this. I don't know enough about mechanical engineering to tell you. But we're still not through this. That makes me sad. What is possibly holding this thing on? There we go. Ha! Look what we found. There's another one. These things are all over the place. One of these has to be the sensors, you know, have these sensors that give this thing orientation. Oh, goodness. And then there's a... I don't know if you guys can see it because I'm bouncing around. But here we've got a flat flexible connector, FFC. There we go. Is there another board in there? How do we get that out? Boy, I tell you, this had a lot more than I anticipated on it. Oh, it would be a pain to route a complex harness through there. They are pretty standard RC brushless outrunner motors. Thank you. Thank you, Mark Harris. Thank you. We're still not in there. We still need to get in. Okay. There we go. So for these things to maintain orientation, they need some sort of an IMU, inertial measurement unit. Being that it's this close to some magnets, I don't know how well a magnetic would work. I wonder if these things go off of the z-axis gravity for orientation and a gyro. I'm not really sure. Oh, there was another mini USB up in there. Huh. Interesting, interesting. Okay. We've got more stuff to look at. I tell ya. I think... let's see, is there one in there? There might be one more board. Hold on a second here. I'm no slouch. We're going to get all of these. Oh, I can't tell. I wouldn't be surprised, but we're going to need a way to get in there. There's only one way I know of, and for that I'm going to back out. And by the way, you should turn down your ears, because it's going to get loud. Uh-oh. Where's the hammer time hammer? Well, it's well built, I'll give it that. By the way, we are in the process of taking Mark Voids a warranty and shortening these things up. So you don't have to spend a full hour with me. I mean, I know you want to, but we've all got things to do. But we're shortening these down to just a few minutes each. So if you don't have a full hour, I understand. Okay, there's nothing else resembling a board in there. Let's get to the grand overview, and then we will look at them under microscope. Oh, Mark, all your friends ran away. That's sad. But thank you for having them join me. All right, so here's what we have so far. This is one of the motor drivers. Or in the side of a motor driver, I believe it was. No. This was the one at the very, very bottom underneath the first motor. So if we're looking at this mechanism, this board was down at the bottom here. Then we've got, these guys are motor drivers. And they may or may not be identical. I don't know yet. I really don't remember where that one was. I'm pretty sure this was at the very, very top, right before you get to the movable connector. And then this one was hidden in the rectangular part, and we've got a wireless on it. So let's take a look at these, shall we? That mini USB is probably connected to one of those two USB ports on the handle, or is a pass-through to your power camera. Yep, that would make sense. We are at 498 subscribers. Thank you, Andrew. Thank you. We are close, people. We need 2 more of you to like, subscribe, smash that bell. 2 more, and we get to take apart a $10,000 production film camera. You have to ask yourself, why not? Don't you like watching me smash things? I mean, who doesn't? All right, so this is the big rectangular board first, and we've got an RF module. The nice thing about that, oh, looks like I've got a black screen I hit for some reason. I think I can turn that off, maybe. There we go. The nice thing about using a module is that you can get the module certified separately. You don't have to have your entire device certified by the FCC or CE or whoever does it in your country. Let's see. We can zoom in. The other nice thing is if you have different countries that you're working with and they need different RF circuitry, it's very easy to do. You just swap out the module. All right, so top side markings are HWB01 1936K3. 24 megahertz crystal. Oh gosh. I can't make out that. I don't remember. I don't know whose icon that is. 24C12SA1915. Not too many connections here. As far as the castellated vias go, I've certainly seen more. So this thing's probably only capable of being a network pass-through module. It probably can't do much more beyond that. But they did some things, like getting the decoupling capacitors sufficiently close, where they could. These modules, this looks like a Harris, you can probably tell me, is this a meandered F-type? What kind of antenna is that? Thank you, Alex. Good call. Good call. Anyhow, we've got a 0 insertion force connector for that little bit of FFC. Get rid of that. Nothing too exciting here. This top one, the module's the module. You just figure out where those are and you pay for them. And then they just made a few connectors. You've got transistors that are probably doing some amount of power regulation. Looks like maybe a LDO of some sort. If you ever wonder why there's Kapton on these things, it's easier for the pick-and-place machine to pick them up and place them. It gives the little vacuum head something to suck onto. On our back side, we've got a little integrated circuit. Top side marking is, I can't make that out on the microscope, S6M3002 XMS. So nothing too exciting here. Some programming or test points that they just put down here. It's always good to put those on one side. The only thing where I would say they could have done a little better job is here you've got 5 pins. Each pogo pin is like 1 Newton of force. That adds up pretty quick. So if you can shift these to a spot where on the other side, like maybe you shift them over here, then you can push down on the other side. You can't really push down anywhere here, so you risk bending your board a little. It's not a big deal. I mean, it obviously worked, but anyways, there's one board. Let's look at the motor drivers next. We've got 2 of these, and by all appearances, they are the exact same. So I'm only going to look at one. First thing I'm noticing, they've got some via stitching around the edges, large copper pores kind of saw the same design on that other board, so probably the same designer. I kind of like copper pores too, but they're not always efficient. And they can cause some other troubles. All right, so we've got two different ICs on here, is that an I128100, 2LRG1945, topside marking, and SD061928C. Backside, we've got the big boy. So we've got an ST Micro, STM32F 030C8T6. Support circuitry, you know, we've got crystal, we've got some test points for programming it. And then looks like we were just designed for connectivity. This is interesting. You've got test points with multiple via pad connectors to the other side. So this is must be the power, I'm guessing. They just want to make sure that there's plenty of it up there, and there is. And here, again, a ton of vias, more so than's really necessary. It's always good to use more than one if you can, but, you know, once you start peppering it, I just don't understand why. And then we've got some resistors and capacitors relatively far away from the IC. I don't know what all those are doing. So anyways, so those are the motor controller boards you guys all asked for. And then we've got, this is the board that leads up to that FFC cable. Nothing too exciting here, same basic design. There is an IC on here. I don't know if we're going to make out the markings. MP683665LA1, 1825. Test points all on the bottom, all on the same side of the board. Always a good thing. Oh, Ferguson's leaving. Thanks, Andrew. Bye, Andrew. And then this is the board at the bottom, right below that first motor, another STM32F 030C8T6 for the top side markings, and a absolute ton of test points. So if you put this thing in a test fixture, all of those things exert like 1 Newton of force, and there's got to be 20 of them here. So you've got 20 Newtons. That's like a textbook sitting on your board. You really want to make sure that you have some pins, some places for pins on the opposite side to absorb that force. This is a multi-layer board. The way that I know that is these vias, right? There's no reason to have those vias there unless they're connecting to internal layers. So anyhow, interesting stuff. There's a lot of technology in these little things. I mean, that's a lot of 32-bit microcontrollers. You know, one for each motor. That's huge. All right, let's back out, and we'll do today's bonus. Original circuit says the 12B is a GMR angle sensor for BLDC motors. Oh, well, there we go. Thank you, Mark Harris. See, you should be doing these, Harris, not me. Also, all of the people you brought along ran away. So, I mean, thanks. No, thank you. I appreciate it. These are just, it's a long time investment. All right. Today's bonus, this PCR Antigen Tester. We're going to see what's inside. Just snaps together. Nothing to it. Little battery compartment on the back side. We've got a way for the battery connectors to hit a big enig pad. My kitty cat Chester says hello to everyone. What is it, buddy? You're fine. All right. So this plastic piece here is connected pretty firmly to the board. The board is separate from what I assume has the electronic parts by this breakaway area here. So they're trying to protect what's ever in here with all of these router cuts. They're really trying to protect it from the rest of the IC. And maybe it's stress and strain. I don't know. I've never seen somebody go to that much to protect it. So here's what we're going to do. We're going to have to break this thing out. Let's see. Wonder if we can flush cut these. So there's these little plastic rivets. And I'm going to see if getting rid of those does anything for us. There we go. Okay, so on the back side here, we've got, I guess that's foam of some sort. Looks textured. Feels like I don't know, like a Band-Aid type rubber. And then there are a bunch of, I don't know, there's got to be a bunch of sensors or something in there. This could be a way to connect those. I don't know. But here we have the front side. So let's zoom in and see what there is to see. Where's the button? Let's see here. This one. So that little Band-Aid type thing is connected to this, which has interesting routing. It's almost like an induction coil of some sort, but I doubt it's an induction coil. We've got LEDs on a part of the periphery. I don't think I carved those off. I think they're just not there. And then what appears to be an optical light sensor right in the middle. Let's go take a look. All right, so I am right in the middle of that board. And we've got certainly an optical sensor. Of what type or measure, I couldn't tell you just yet. I'll tell you, it reminds me a little bit of the AMS sensors when they acquired Taos, Texas Advanced Optics, like the SCL. It's not the SCL, but it's the 230. But what I see in here, and what I'm trying to show you, is you can see an array of squares in the silicone there. And I don't know if those are significant. And I'm trying to make out how many there are, because it's an irregular pattern. 1, 2, 3, 4, 5, 13, 14. I see 14 in the body, but I can't really make out anything else. But something's happening in that optical sensor. Just a couple connecting vias, and then it's isolated from this induction coil looking thing. Come here, buddy. Come here. There you go. It's isolated from this induction coil looking thing, which isn't an induction coil because these things run right back. So, sorry, Chester. They run right back on each other, which means they can't be inductive. Maybe they're there to heat? Maybe they're heating coils. Heater, yes, original circuit. Yes, you figured it out 5 minutes before me. Thank you, Mark Harris. Thank you. You're good, buddy. You're good. All right. So then that is then why they've isolated the rest of the IC. So if that's a heater, And that tape that I saw was a thermal tape. That would make a whole lot of sense. So then they're trying to isolate the rest of the PCB from the heat generated there. That makes sense. All right. Here we've got another ST. What do we have? The ST32F030. What did we have before? We had the STM32F. So these things have to be passing. Let's get that container out of here for a second. It's not high enough. Let's see if I can break something off. There we go. And focus. All right, so here is our reaction chamber. There's a little needle that is what connects to that tube full of liquid that we just saw. So it gets into here, and then it goes and it spreads into the various chambers. So these things must have some amount of, some chemical in here that the opacity changes when it encounters the coronavirus somehow. And then there must be some controls. So then you shine the light up through each one of these and you measure how much is transmitted back. And somehow they figured out where it goes from there into yeah, they figured out somehow that the light coming out makes a difference. Interesting. Okay. So the heater heats it up and it creates the reaction. The LEDs do their thing. You know, you shine light through each one of those chambers and you figure out how much light comes out. How do we get the... So then we've got signal here over on the side. Do we have more up here? Yeah, so wrapping around those cutouts, those route outs, we've got, looks like 7 pins, which is plenty, to activate those LEDs and then get a signal reading. And then our STM figures out, you know, it does whatever it wants to. And then it's got to light up these 2 LEDs depending on pass or fail. So, interesting, interesting. Hatched copper pore on the back side. For reasons that are unknown to me, my only assumption is they're trying to reduce the heat transfer yet again. I would think those cutouts would be sufficient, but what do I know? Test and program pads on the back side. Pretty basic. All right. Well, dear viewer, it has been a blast. How did we do on subscriber count? Where are we at? Did we get to 500? Is anybody there can let me know? We had a ton of viewers, a ton of playback. Thank you to Original Circuit for making that happen. That was very kind of you, sir. Check out his altiumlibrary.com, largest free open source Altium library out there. You guys will probably find it useful and maybe contribute, maybe don't. But if you don't contribute, I'd really appreciate you saying why and directing the message right to him. But maybe copy me on it so I can enjoy it too. It's been a pleasure. Mark Voids a Warranty is sponsored by Advanced Assembly and Royal Circuit Solutions. This might have been what pushes us over the top to 500 subs. Who knows? Maybe, maybe. But with that said, I certainly appreciate everybody's time here. If there's ever anything that you want to see, you think it's an SI1133 ambient light sensor? I'd buy that. It's certainly an ambient light sensor. I haven't played with them recently enough to know whose looks like what. So I'll take you up on that. We're at $4.99. We just needed one more. We're so close. So close. Again, tell your friends, tell your neighbors, tell your friends' neighbors, tell your neighbors' friends. We need one more to be able to take apart that huge lens. Anyways, if you ever have any requests, if there's anything you want to see, let me know. We've got a Discord channel over at teachmepcv.com that you can join. And also, I'll let you in on a little secret. We've got a design competition coming up in about a month, a little less than a month, where you might win something or not. I don't know. I don't care. But I appreciate everybody's time. AMS, the TSL 25403. See, Watermill. Harris, you changed. I made it? Oh, because original circuit, just subscribed twice. 500! Woo! All right, guys. I'll see y'all next Friday on Mark Voids a Warranty. I'll hit something with a hammer then.